is going to be most important. This is a small world and becoming smaller every day. The cause of freedom is under challenge all over the globe. This will give us the means to move our forces faster. Latin America, Middle East, Asia, where freedom is endangered, where our allies are fighting for their security. This plane and those that will follow it will mean that the United States is always present. Now it will be planes, maybe stationed here in the United States, but able to move across the Atlantic Ocean, fastest cargo-carrying plane in the world, across the Pacific, carrying dozens of troops, tons of cargo. This means the power of the United States will be felt on behalf of the cause of freedom all over the globe. And it is with great pride and satisfaction that I join the Georgia delegation, and indeed the people all over the country, pressing this button, which will make formal the rolling out of the first plane, which will happily be followed by dozens of others. I want to join with the members of the Georgia delegation in expressing our commendation to the men and women who work at Marietta, work in Georgia, work indeed throughout the United States, as Senator Russell said, beginning a great new effort to strengthen the security of the United States. By the unveiling of the C-141 StarLifter. This truly strategic aircraft will greatly increase the ability of the United States Armed Forces to support our policies by giving us modern means to move our men and equipment to trouble spots, actual or potential, in minimum time.
In the mid-1970s, the U.S. Air Force stressed the urgent need to improve our nation's strategic airlift capability. Definite objectives were set, and a series of alternatives investigated. Of the several approaches examined, including additional new C-141As or other aircraft, a stretched version of the C-141A StarLifter into a C-141B with air refueling capability was determined to be the most cost-effective and 2 to 3 times less expensive. The result, a fly-before-buy prototype first flew in March 1977, followed by a production first article YC-141B verification airplane in February 1979. On February 14, 1979, a C-141A, scheduled to be the first C-141B production aircraft, arrived at Lockheed Georgia. Major configuration changes included a 23 1/3 foot fuselage stretch and installation of aerial refueling capability. After receipt, inspections, and washing and stripping of paint from the areas where the fuselage would be parted, The first stretch production aircraft was moved immediately into the vast production area of Air Force Plant Number 6. Parting of the first production model took place April 23, 1979. The operation is a series of carefully calculated moves. First, the nose section is separated and then pulled forward from the stationary center fuselage section to open the area for the 160-inch forward plug. When the nose section is free, the aft fuselage section is separated and pulled back to open the area for the 120-inch aft plug. The commander of Warner Robins Air Logistics Command and other Air Force dignitaries witnessed the first production parting. In order to install the two prefabricated plugs, the three aircraft sections rigged in a fixture as one unit are moved to the next forward position. To facilitate positioning of the prefabricated barrel section plugs forward and aft of the wings, a specially designed crane-held jig fixture is used. When complete, the added fuselage sections contain all of the same equipment that is in the present C-141A configuration. The center fuselage is also reinforced due to the higher bending loads created by the additional length. After installation of both plugs and the aerial refueling receptacle structure on the upper fuselage just aft of the flight deck, the aircraft is moved onto an air pad system. This air pad technique permits sideways movement across the production floor to the final portion of the production line. The functional systems that have been removed from the stretch work can then be reinstalled and checked out for proper operation. The smooth movement of the aircraft across the production floor is due entirely to a cushion of air, and amazingly enough, the air pressure required to float the 70-ton StarLifter is only about 25 psi. This technique reduces manhandling to a minimum and contributes a significant savings in production time. The second production unit to be modified after the prototype became a static loads test article. This aircraft received proof load tests, which simulated flight conditions up to 100% of those expected in operation.
Delivery testing of the YC-141B was conducted at AFSC's Air Force Flight Test Center, Edwards Air Force Base. The YC-141B uses the same dual-rail cargo deck as the basic aircraft, but it carries three additional 463L cargo pallets. Flight Test Center people experienced in numerous aerial delivery tests conducted this series. Standard C-141 checklists and procedures were evaluated as satisfactory for the stretch version. Among the tests conducted were extraction parachute tow tests. These included deployment, inflation, towing, and cutaway. This is a cluster of two 28-foot diameter ring slot parachutes. Before live personnel drops, retrieval tests were made of 60 static lines with weighted bags. Tests on articulated dummies reduced the risk of injury. Personnel airdrop tests included 2 sticks of 8 jumpers dropped simultaneously. Army and Air Force jumpers with experience in the basic C-141 were used in these tests. Jumpers commented that there were only slight differences in jumping from the stretch 141 and the basic aircraft. Single platform loads weighing from 2,060 to 34,000 pounds were test dropped. Loads less than 15,000 pounds produced negligible pitch attitude change. More than 15,000 pounds produced definite aircraft pitch up, then pitch down. Aircraft pitch changes were about the same as for the basic C-141. On sequential platform tests, each load extracted the parachute of the next load. 3 loads with a total weight of nearly 70,000 pounds were dropped. It took 6 hours to rig the sequential drop in the aircraft, and only 11 seconds for the air drop. The aerial delivery tests were successful. All objectives were met, and no problems in platform or personnel airdrops were encountered. The YC-141B, or Stretch StarLifter, brings increased cargo capacity and more effective use of Air Force resources. To further enhance the Military Airlift Command mission, the YC-141B, or Stretch version of the Lockheed StarLifter, was equipped with an aerial refueling capability. At AFSC's Flight Test Center, aerial refueling tests were flown by 8 pilots, including both Flight Test Center and operational pilots from Military Airlift Command. The Stretch 141B, with its 23-foot longer fuselage, was stable as it approached the boom. Boom operators from the Flight Test Center tossed the Stretch into position. Various boom disconnect positions were tested: center, right, and left. Various relative altitudes were evaluated, as well as combinations of gross weight, center of gravity, and airspeed. 275 knots proved to be the best airspeed for all gross weight combinations. Flight Test Center boom operators, experienced in numerous refueling tests, worked closely with the YC-141B pilots. Positions were verified by tanker director lights. Some 50 hookups and disconnects were made during the tests to verify the full range of acceptable speeds and positions for refueling. A chase aircraft was used for safety and photo documentation of the YC-141B and AFSC's specially instrumented KC-135 tanker. Among the final tests, a day-night evaluation was made. Receptacle illumination lights provided good visibility. YC-141B pilots reported excellent visibility from normal seat positions and no problem maintaining the boom contact position. Boom operators, constantly alert for receiver handling problems that could require boom separation, reported excellent visibility of the receiving aircraft and the refueling receptacle. The tests were successful, and a certified aerial refueling envelope was established.